Today you will be learning lesson 4.1 about using graphs to relate two quantities. Okay? This section will also contain information about tables and how we use tables to make graphs. Okay? A graph, okay, is a visual representation of a relationship between two variables, and that's the key part to a graph. Okay? Those variables are what we label along our x-axis, which is horizontal, this is x, and our y-axis, which is vertical. Okay? So when we're talking about variables, we're going to label one variable here and one variable here. Okay? Whatever is represented, we label along that x-axis and that y-axis. Okay? So here we have a graph. Okay? The first thing they ask, what are the variables in the graph? Okay? Remember, the variables tell us about the graph. So when I look at this, oops, sorry about that. So when I look at this, okay, my labels are my variables. So my variables are length and time. Okay, they're what is being represented on that x and y axis. Okay? And they want me to describe how the variables are related at certain points of the graph. And to help you do that, I have a couple questions down here at the bottom. Okay, so when we are looking at this picture, is the length of the board increasing or decreasing with time? Okay, well, right up here, if we're at the top of our graph, our length has to be bigger, and as we move down, it's getting smaller towards 0. Okay, so when we start, it's long and we're going down, so that length of the board is decreasing over time. Okay? And then it asks, the length of the board is constant or decreasing while you are actually cutting the board. And where we're cutting the board are on these spots right here. Okay? These vertical lines is where our cuts are. Okay? Because that's when the length of the board is changing. Okay? But the length of the board during that cut, since it's not changing, is actually staying constant. Okay? During that cut, that board is staying constant. It's not changing. Okay? It's not getting bigger. It's not getting smaller. Okay? So during the time shown on the graph, if we look, there's 1, 2, 3 spots where our board gets shorter. So that board is being cut 3 times. 1 cut, 2 cuts, 3 cuts. Okay? And at the end, our graph is or is not a piece of the board left. Well, since we're not down here at 0 yet, there is a piece of the board left. So it asks me to describe how the variables are related at various points on the graph. I could say that the board starts out long. Okay, we always want to talk about our starting point. That's an A there. Starts out long. Okay, is cut 3 times. It's cut 3 times until it reaches its desired length. And you could go into a lot more detail, but it starts at a longer length. It's cut 1, 2, 3 times until it gets that desired length. So we're saying it doesn't end with nothing left. Okay, so let's look at another one of those. Okay, so what are the variables in this graph? Describe how the variables are related at various points on the graph. Okay, and your variables are labels on your x and your y. So our variables for this problem are the cost and the number of minutes of calls. Okay, again, we can find that, the label on our y-axis and the label on our x-axis. So, and then to help us describe that, when we look at this, the cost of the cell phone bill in June, because it's only talking about June, increases or decreases with the number of minutes of calls. Okay, if I look at this, here the cost is staying the same, but at the end, it's going up, which means our cost is increasing. Okay? Second question, the cost of the cell phone bill is in June is constant or increasing for the first part of the month. Okay, if I look here, this cost is not changing, so that means it's constant. Okay, so if I want to describe these variables at certain points on the graph, I would say the cost remains the same. Okay, it means constant. Remains the same for the first few minutes of the call. Then it then increases, and if you look at that, it increases pretty steadily. Okay, it increases. So if it is increasing steadily, it increases each minute after that. Okay, when I say it, I'm talking about the cost. Okay, so the cost increases each minute. Oops, forgot the word minute there. Each minute after that. So there's a description of that graph. Okay. The third one, describe a real-world relationship that could be represented by the graph sketched at the right. So if we look at this graph, okay, it's starting, okay, at nothing. It's going up pretty quickly. It's still going up here. At C, it's staying the same. D, it's going down quick. And E, it's going down little bit by little. So if I think about real life, and you could come up with a lot of different relationships for this, but I'm going to talk about the amount of water in a cup. Okay. Okay. So if we want to describe this whole entire relationship, we might start by looking at line part A. Okay, what is happening in this part of the line? And one thing I could say about it is that I'm quickly pouring water into a cup. Okay, right? If I'm pouring water into a cup, it fills up pretty fast. Okay, I notice that cup is getting pretty full, so for part B, I'm still pouring water into that cup, but now I'm doing it slowly because I don't want that cup to run over. Okay, part C, since it's not changing, I've stopped pouring water into that cup and that water's just sitting there on the table. Okay, part D, okay, comes out rather quickly, so I must have accidentally spilled over that cup of water. Okay, and part E, still coming out, so when I spilled that cup, I must have put a hole in that glass, and now it's leaking out little by little. Okay, and notice there's an arrow here, so it is going to continue to leak until it gets to that nothing mark. Okay, so that's one representation for that graph. Okay, you could also talk about this about you're driving somewhere. Okay, you can talk about distance over time. So maybe, for example, you leave your house in a hurry. Okay, you slow down when you're getting closer to your friend's house. You stop and wait for them to get in the car. Okay, and if we're talking about distance, you quickly drive back towards your house. Okay, and then maybe your mom sees you driving too fast, so you slow down until you get back home. Okay, different representation, but here they just asked you to write a real-world relationship, so there's a couple of options for you. Okay. The second half of our lesson is going to talk about tables, okay, and still about graphs, but the next question is about a table. Okay, so tables are also used to represent relationships between two pieces of data. Okay, their data, okay, often represents precise information that we use to make those graphs. So it would be those points. Okay, if I think back about that last graph we did, a table might tell us this starting point. this starting point, okay, this point, this point, this point here, okay, to tell us these are the changes in our graph. Okay, and we could find that information, this is precise stuff, in a table. Okay. So the table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Which graph could represent the data shown in the table? Okay, so what's happening in this table? Where number of uses when it's not used, we know that there's 5 ounces in the bottle. So every one of these starts up at a certain amount. Okay, after one use, they've used 0.2 ounces. Okay, so it's decreased a little bit. If I look, all of these are decreasing. Okay. After the second time, it's down to 4.6 ounces. So it's down some more, right? Still all going down, so that's not so helpful. Next one, there's still 4.4 ounces. So when I look at this, if that's the last piece of data in my table, this graph ends up at 0, okay? Saying the bottle is empty, so we know it can't be graph number A, okay? B, same type of thing. If this is 5, we can think about this as being 1, 2, 3, 4, and 5, okay? If I'm way down here, there's about 1 ounce left, so B isn't going to work either. But when I look at C, it's going down, but it's not going down a lot. So the best representation of that data would be graph number C. Okay? So we use those tables to help us make a graph showing us precise pieces of our information. Okay? So when you sketch a graph, some things you need to remember is a horizontal line shows no change, okay? It's constant at that spot. Okay? If I'm not moving, my distance is going to remain at 5 feet, okay? It's a constant amount, okay? We use a diagonal line slanted up to show something's increasing, so the farther I go, I'm going to go up, okay? When I decrease that distance, we're going to go down, so our line's going to be pointed down, okay? And then the slant, or the slope, if you remember from last year, of that line tells you how fast it's changing. Is it changing quickly? Okay. Is it changing slowly? Is it changing gradually? Okay, those are all words you should use when you're describing a graph and when you want to be drawing a graph. Okay, those are key pieces of information. So, suppose you start to swing yourself on a playground swing. You move back and forth and swing higher into the air. Then you slowly swing to a stop. What sketch of a graph could represent your height from the ground might change over time? So they're telling me my variables are time and my height off the ground. Okay, and one thing to think about when you're on a swing is that swing on the ground, are you starting at a height of 0? No, you're not starting at a height of 0. You're starting somewhat off the ground, okay? It says we move back and forth. So when I move back, my height's actually going up, okay? It's going to come to a maximum spot, and I'm going to come back down to where I started, okay? And then when I go forward, I'm going to go up, and this time it says I go higher, okay? I'm going to get to that maximum height, and I'm going to start coming back down to where I started, okay? And then it says I slowly swing to a stop. So I'm going to go backwards again, slowly, and I'm going to go to that maximum height again, and I'm going to slow down until I come back to my stop. And if I'm stopped, that height is constant. It's not changing. So we have that horizontal line at the end, okay? And just like any other time you draw a graph, you should always label and title your graph, okay? Or label your graph with a title. So we would call this a playground swing. Because that's what we're talking about in that word problem. Okay, so don't forget to put a title on your graph. So let's look at a couple more of those. Okay. This one's talking about the average temperature steadily decreases over the course of a football season. So our title is football season, or maybe we want to say the football season. Okay, and we're talking about temperature over the course of the season. So maybe we want to say time, okay, or you could say length of season, but here we're talking about the temperature. Now this will obviously vary depending on where you're living, but since we live in North Dakota, let's start with North Dakota, okay? The start of the football season, okay, depending on which sport you play for, but in the middle school, starts in August. So that's about, pretty warm outside still, okay? And it steadily decreases, means it's a straight line, and decreasing goes down, okay? And you might even play until it gets to the winter. And if you're playing professionally, if you were playing for North Dakota, it would even go all the way to 0, okay? So it's steadily declining throughout the season. Okay. The second one, during a trip, your speed increases during the first hour, or increases during the first hour, and decreases over the next 2 hours. So down here, we're talking about hours. Okay, that's our time. And here we want to be talking about our speed. Okay, this graph is about our speed. Okay, and we're talking about a trip. Okay, so it says during that first hour, and our data is only over 3 parts. So I think about this, we have 3 sections, right? So our speed increases over that first hour, right? Then it decreases over the next 2 hours. So that speed went up for about 1/3 of my graph, but for the next 2/3, it's got to be about twice as long. It needs to be going down. So there's an example of that one. And we're going to try one more before we let you look at some on your own. Okay? For a race, you swim 1 mile, you run 10 miles, and you bike 25 miles. Sketch a graph to represent the relationship. Label the axes with the related variables, and then it wants you to talk about the important points on the graph. Okay? So for this one, we're talking about a race. Okay, and that type of race, if you want to be pretty specific, is a triathlon because you're doing 3 different events. Okay? On the bottom, we're going to talk about our time. Okay, most of these graphs we're working on are going to be time. And here, we're going to talk about distance. Okay? Now, when you look at this, this is over quite a bit of distance. It's 1 mile, it's 10 more miles, and then 25 miles. So we think about this, 25, 35, 36 miles along this amount of time. Okay? So for the race, I swim 1 mile, and this was going to vary too by person, okay? But for me, I'm a pretty slow swimmer. So when I swim for 1 mile, I'm not going to go very fast. So that 1 mile, okay, is not going to be very high, okay? But here's my 1 mile, okay? I then run for 10 miles, and I'm actually going to change that because I'm not a pretty fast swimmer, okay? So this is how long it takes me to swim 1 mile, okay? Then I get to run 10, and I'm a runner, so I run a little bit faster than I swim. So now I need to run for 10 miles. Okay, so this was only 1 mile, 10 needs to be about 10 times that length. Right? And then I bike for 25 miles, and I can definitely bike lots faster than I can run. So that speed is going to change the remainder of my graph. Okay? So what are the important points? And this didn't quite work out right here, but there's a dot right here, okay, where you should be able to see that this was my swimming speed. Okay? It wasn't very fast. Okay? Then it increased some as I ran until I got to bike for 25 miles. And if you look, I can tell that that swimming part is the shortest. My running is longer, but the biking is the fastest, and that speed on the bike is faster than when I get to run, okay? And my swimming speed is the slowest. Now, depending on if you're a swimmer, your graph might look different, okay? But you should be able to see the different lengths, so about 1 mile, 10 miles, 25 miles, okay? And so maybe even over here you want to label it in miles rather than just distance, because they are that specific for us. Okay, that would probably be a better idea. But you should be able to see 3 different spots in your graph, and those are those important points that they're talking about. So the important points is your change from your swimming to running, your change from your running to swimming. Okay, those are things you should be able to see when you're drawing this type of graph today.